Welcome! This is Mr. Ranieri here. I have very exciting news. I've just bought a new gaming headset just to record better quality videos for you. In this video, we are learning about independent events. We say that events are independent if they don't affect each other. So the outcome of one event does not change the probability of the other event. Let's give some examples here. So I've got a question. Are these events independent? I flip two coins at the same time and I check whether each lands on heads. Are these events independent? What do you think? These events are independent because if I get a heads on one coin, that doesn't change what the other coin will do. It doesn't affect whether the other coin will land heads. I have another example here. Are these events independent? The chance of rain today and the chance of rain tomorrow. So if it's really rainy today, does that make it more likely to be rainy tomorrow? These events are not independent because if it's rainy today, then there's probably a good chance it'll be rainy tomorrow as well. They are not independent. They are dependent events, actually, which is the opposite of independent. Now, independent events is a useful concept, partly because we can calculate the probability that two independent events will both occur, that they'll both happen together. And that's easy. All we have to do is multiply the probabilities together. In other words, in a formula, the probability of event A happening and event B happening is the same as the probability of event A times the probability of event B happening. We multiply them together and then we can find out the chance that they will both happen. Let's look at an example to see how this works. In this example, one lucky middle school tutor group will win a pizza lunch. We will randomly pick a year out of 7, 8 and 9 and a house out of BH, CN, KM and MS. Let's think about these two things separately first. First of all, what is the probability of selecting a BH class? To do this, we can write the probability of BH is, out of these events, out of these outcomes, how many of these outcomes match BH? Just one of them, which is this one here. Just that one matches BH. Okay, and how many outcomes are listed here? There are 4 outcomes. So looking at just the house, it's a 1 out of 4 chance. Okay, now let's just look at the year. What is the probability of selecting a year 8 class? The probability of selecting a year 8 class is, well, one of them matches out of 3 in total. One outcome matches out of the 3 outcomes in total. So I've just looked at these events separately, and these two things are independent because I'm randomly picking a year and completely separately randomly picking a house. So they are independent events. We can look at the probability of selecting BH and year 7. We can use this formula because they are independent events. Well, the probability of getting BH and picking year 8 is the same as the probability of BH. To split it up, what symbol goes here? What do I have to do to these individual probabilities? Do I add them, subtract them? I have to multiply them together. So, what is the probability of getting Bleeby Howard? We already figured that out, right? The probability of getting Bleeby Howard, BH, is 1 over 4. I copy down the times sign, and I'll replace this part here with the probability of choosing year 8. Ooh. There we go. 1 out of 3. Good. So now I can just multiply these fractions together. To multiply these fractions together, I write my equal sign and my fraction bar. On the top goes these two numbers together. 1 times 1 makes 1. And on the bottom, I've got the denominators, multiply the denominators together. 4 times 3 is 12. So there's my answer. That is the chance that we pick BH and Year 7. So we've converted a fairly complex problem into 2 easier problems. And that's a really common thing in maths. Take a complicated problem and break it down into 2 smaller pieces. Just to show you that this works, and a little bit to show you why it works, let's draw a 2D grid to show the sample space, all of the possibilities. And we'll circle the outcomes for selecting BH and, I've written Year 7 there, but really I meant Year 8. There we go. All right, so a 2D grid means I've got my axes here, my 2 axes, my horizontal and vertical axis. Down here, I might put the year, and over here on this axis, I might put the house. What are the outcomes for the year? They are 7, 8, and 9. And what are the possible outcomes for the house? BH, CN, KM, and MS. Those are the 4 outcomes. And on each of these grid intersections, so for example, the 7 and the BH, I'll put a dot there. The 7 and the CN, I'll put a dot there, and so on, until I've got dots on all of these possibilities. How many outcomes can you see in this sample space? How many dots? There are 12, right? And how many of them match getting BH and Year 8? How many of these 12 dots are both a BH dot and a Year 8 dot? Just one of them, just this one. So the 2D grid also shows us that the probability of getting BH and getting Year 8 is 1 out of 12. This is a really powerful idea, independent events, for lots and lots and lots of reasons. But one of them is we can see just how unlikely it is that 2 events will happen together, that one event will happen and the other one will happen. All right, this is Mr. Ranieri signing off, and I'll see you in the next video. Bye, everyone.